Armstrong is a small, private crime lab in Tarrant County, Texas. They employ about 30 people, and the lab is accredited through a national accrediting agency called ANAB, or ANAB. In comparison to other crime labs across the state, Armstrong is relatively small. By comparison, Texas DPS runs 16 different labs across the state and employs roughly 660 people. On their website, Armstrong claims to be the first Texas-based, fully accredited lab capable of quantifying THC in plant material and non-plant material. For decades in Texas, if you were arrested for possession of marijuana, possession of any THC extract, possession of a cannabinoid, a possession of CBD oil, the prosecutors really had no reason to be concerned about the concentration of THC in marijuana. That all began to change in 2018. The Federal Farm Bill Act of 2018 legalized at the federal level the possession and sale of hemp. Hemp and marijuana are scientifically the same plant. Botanically, they're both referred to as cannabis sativa. Yet hemp is cultivated to have a low concentration of the psychoactive ingredient. Specifically, that's delta-9 THC. Therefore, marijuana is any cannabis sativa plant or product that has a concentration greater than 0.3% by dry weight. In 2019, the Texas legislature decided to eliminate the confusion between the now legal hemp at the federal level and the fact that it was still illegal in Texas. So Texas passed legislation mirroring that portion of the Farm Bill Act. So Texas now also requires a distinction between marijuana and marijuana byproducts that have a very low level of THC and products that have a concentration greater than that threshold of 0.3% by dry weight. When the law changed in 2019, prosecutors and crime labs across the state realized they had a problem. No lab was equipped or qualified to test for the concentration of delta-9 THC in any suspected sample. Further complicating this matter is the fact that cannabis contains over 100 compounds known as phytocannabinoids, of which delta-9 THC is just one. We obtained the standard operating procedure for Armstrong Forensic Lab that outlines how they generate these lab reports with a purported THC concentration. What we discovered is they are using a gas chromatograph with a flame ionization detector. They are not using a gas chromatograph with a mass spectrometer.
Tom Rosano, and I'm toxicologist and director of the National Toxicology Center at the Center for Medical Science. Definitive drug analysis really can be defined as a selective identification of drugs and their metabolites. I add to that particular definition myself that selective identification needs a level of certainty that allows for molecular information. I translate that by saying, therefore, it really is chromatographic separation and interfaced with mass spectrometry that allows for molecular information. And the more information that we gain about the molecular species, the more we become certain as to the determination that is being made. So definitive testing really needs to have the components of selective identification and molecular information.
The gas chromatograph combined with the mass spectrometer has become the gold standard for forensic substance identification because it uses a 100% specific test. It positively identifies the presence of particular substances in an unknown sample. The graphs highlight the difference between the capabilities of these two devices. The flame ionization detector has a large area under the graph. They're not as selective, and when it comes to testing for a cannabinoid, it is extremely important that the test shows specifically delta 9 THC in marijuana as opposed to any other cannabinoid. As far as we've seen, Armstrong Forensic Lab is the only lab in Texas that's claiming to be able to use a GCFID to generate quantified THC results. In this email thread between a representative of the DA's office and representatives of the Texas Forensic Science Commission Advisory Board, the issue of using GCMS to test for THC concentrations in light of the new law is brought up, specifically in regards to Armstrong Labs' use of the GCFID. This email conversation is taking place between Lynn Garcia, who's General Counsel to the Texas Forensic Science Commission, advisory members Dr. Peter Stout and James Miller of the Houston Forensic Science Center, Brady Mills, who is the Deputy Director of the Texas DPS Crime Lab, and Don Boswell, who is, or was at the time, the Chief of the Conviction Integrity Unit at the Tarrant County District Attorney's Office. Dr. Stout is the CEO of the Houston Forensic Science Center. He has over 15 years' experience in forensic sciences and toxicology and has a doctorate in toxicology. James Miller has been in forensics with a primary emphasis in controlled substances for over 25 years. Early on in the email conversation, Dr. Stout explains the process that Armstrong Lab is using to generate these purported results with THC concentrations. Dr. Stout explains that Armstrong is using GCFID. As the conversation continues, both Dr. Stout and James Miller express concerns about using GCFID to quantitate THC concentrations. Dr. Stout discusses the vulnerability of using small private labs, who might put revenue over results. Dr. Stout points out some shortcomings with even their published results, including the lack of a measurement of uncertainty.
Hemp can smell and look like marijuana, and vice versa. There's no real way to distinguish this, and I cannot tell you, no one can tell you, which has more THC or not without the chemical testing.
THC is a notoriously what we call lipophilic compound. It likes to stick to stuff. So it's a very finicky molecule to analyze for. The extract out of plant material is difficult enough. Then you start adding all kinds of sticky stuff with foodstuffs and oils and everything else. It becomes really difficult to extract this stuff and extract it reliably and consistently. It damages equipment. It is difficult to establish the calibration to reliably measure this percentage in a solid. This isn't like a liquid. It may not be homogeneous within the solid. All of these things are analytical challenges, and that's part of this measurement uncertainty that occurs, that I may be able to say I measured 0.2%, but my margin of error is 8%. What does that 2.2% mean?
And we're going to have to determine what is our uncertainty of measurement, so that when we report a value, what is the uncertainty associated with that value? If the value is 0.3%, and I find, and this is not a made-up number, if I find that my uncertainty is 8%, we now have to question the value in doing that testing.
James Miller with the Houston Forensic Science Commission puts it in terms that anyone can understand. Since the new definition of hemp or marijuana requires knowing how much, if any, delta 9 THC is present, we have to identify and quantitate delta 9 THC specifically. I feel that this requires the use of a GCMS or LCMS for identification. How the quantitation is performed can vary, but you have to be able to show that you are only quantitating delta 9 THC and that there are not any interfering substances, including other cannabinoids, that might be present.
Mass spec, definitive methods are really necessary in this day and age to really respond to the needs and the diversity of drugs that are out there. The benefits of definitive drug analysis are benefits that come to those who are receiving results. The benefits are the expanded knowledge of the number of agents that are present and the education of all of us as to the extent of drug use in our communities.
An overly simplified explanation of a gas chromatograph is it's a device in which you can introduce a solution that is ionized, and those separated ions are going to travel down a tube at different speeds and rates so that separation occurs. If a compound is made up of many different ions, then as it passes through this long capillary tube, you're going to see ions starting to get separated out. The coating within that long tube is also designed so that different particles are going to move at different rates. In essence, it's a long tube that's designed to separate out different types of ions. The longer the tube, the more separation will occur. For a drug sample, what they'll do then is take a substance that's a solid, dissolve it into a solvent, introduce an inert gas, and essentially force it through this long capillary tube, waiting for the different drug particles or ions to separate out as it gets close to what is ultimately a detector. And here it's the detector that is the important distinction, whether a person or a lab is using a flame ionization detector or a mass spectrometer. A flame ionization detector, as its name implies, uses a flame to ignite the ions that are traveling through and out of the mass spectrometer, and it's going to measure the electric charge created by the burning particles. In other words, the ions that are traveling down are going to burn, resulting in the production of carbon ions. That electrical charge that's created by the flame is going to be measured by an electrometer. It's going to be amplified, and then it's going to be pumped out into a computer that'll produce what's called a chromatograph that shows you various peaks of substances coming out at various times. The mass spectrometer works differently and much more precisely. It takes only positively charged ions or electrons, and as these electrons pass through the mass spectrometer, they come across an electromagnet. The electromagnet causes these electrons to deflect or bend at different rates, and as a result, the sensor at the end of the mass spectrometer will be able to differentiate between different ions, electrons, very precisely. So you get a much more accurate measurement of what was contained in the unknown sample. Additionally, a mass spectrometer is many times more selective than the flame ionization detector. The mass spectrometer is the gold standard for determining what ions are contained within an unknown substance.
We want to make sure that we do utilize the correct and right testing, but there are also some other qualifications in the statute, such as you need to do your testing on a dry weight basis, meaning the samples have to be dried. Well, at what point are they dry? Because what I test today and then I test next week, the results may be different and probably will be different.
The reality is you can walk into almost any store in Tarrant County and purchase a product containing CBD, and you're only one police stop away from a potential arrest and having to defend yourself in court. As a citizen of Tarrant County, you have a right to expect reliable results from crime labs and criminal prosecutions that take place based on valid scientific methods.
You could see the scenario where the agricultural testing demonstrates that the product leaving the farm on its manifest is below 0.3% THC. Stuff happens in between, and either that shipment or parts of that shipment end up in the hands of law enforcement and end up in our lab. I could dry it down farther. meaning the THC that's present is now looking like a larger percentage. So it left the farm hemp. My testing then shows it's 0.8%, and now it's marijuana. That's a problem for the farmer because now what left as a legal product is now a criminal offense. And I don't know what a dry oil means.
Right.
And if I'm a criminal defense lawyer, I'm using the video of this board meeting, right, what Peter just said, right? I am putting that, I'm showing that to the jury.
I don't think a layperson would look at something that sloshes around in a tube and looks like a liquid, even if it is anhydrous, as dry. So I don't know what dry means for an oil.
Legislation did not state.
No, it just says dry. And it says very specifically delta 9 tetrahydrocannabinol. There are delta 8, there's delta 6, there's delta 10, there's other cannabinoids. Marijuana itself, cannabis sativa, is a combination of what, some 90 odd different cannabinoids?
It's a natural product, so it's not
It's a natural
surprising.
product, but the law is specific to delta 9 tetrahydrocannabinol.